Okay, guys, we are going to do rotational and circular motion today. Okay, let's begin. Angular displacement and angular velocity. Okay, these are two terms that we need to understand first. Let's do this. Angular displacement is a term used to represent the angle itself. Okay, so angular displacement is nothing different from angle itself. The same as the angle. If there is an object starting off from a certain starting point, this is the center. This is an object that's moving on a circular path. Okay, and it has covered certain distance. So while moving from this point to this point, it would have covered a certain angle, right? This angle that it covers is called angular displacement. Understood? This is usually measured in physics. We measure it in radians. Normally, most commonly in math, we use degrees to measure angles, right? But the relationship between degrees and radians is that 180 degrees equal pi radians. Understood? You need to know this conversion. Apart from that, you also need to understand the fact that this is the radius of a circle. This is another radius, and this area which is covered right here, this is called the arc length, which is usually represented by the symbol S. There is a relationship between these three quantities. S equals r theta. Understood? S equals r theta. So S is the arc length, which is the linear displacement. Okay, S is the linear displacement because it's just the displacement being covered. It's the length, right? So the linear displacement equals radius multiplied by the arc length. Similarly, we have another formula for circular motion. If we divide both the sides by time, you get another formula. What is this linear displacement divided by linear time? Yes, guys? Displacement divided by time, is that a formula?
Yes.
That's
Yeah.
linear velocity, right?
Velocity, yes.
And angular displacement divided by time is angular velocity, which is represented by omega. Okay? And R again is a link between these two quantities as well. So V is equals to R omega is the formula. Okay? S equals R theta is one formula. V is equals to R omega is another formula. Now, S equals R theta is the relationship between arc length, which is the linear displacement, and angular displacement, right? Similarly, this case as well, this is linear velocity, which is linear velocity is also called tangential velocity because its direction is directed at the tangent to the circle. And this is angular velocity. Angular velocity can also be calculated using another technique. Because we know that angular velocity is the change in angular displacement divided by time, right? It's the angular displacement divided by time. What do you think is the time taken to complete one rotation of a circle? Complete one rotation, meaning one revolution of a circle. What would that time be called? Amal Rafi. If I complete one revolution of a circle, can I call this time, the time taken to complete one cycle, the time period?
Yes.
Because
Yes.
this is a time period, what's the angle that an object covers when it completes one cycle?
360.
What angle does it cover when it
360.
completes one circle? Sorry?
360.
360 degrees. What if we convert that into radians?
2 pi.
2 pi radians, exactly. This formula is for angle measured in radians only, okay?
Okay.
Radians only. So this is gonna become 2 pi over t. This is another formula for calculation of omega. And as you know that 1 over t is actually frequency, right? 1 over time
Yes.
period is frequency as well. So 2 pi f. Now omega equals 2 pi f. This is one of the most frequently tested formulas in physics. Okay, you need to know this formula where F represents what? Frequency.
Frequency.
Okay, then we need to understand the relationship between linear and angular quantities. Okay, there is also another acceleration called linear acceleration and angular acceleration. So basically, now this is linear velocity, okay? It's directed as a tangent to the circle itself. Whereas angular velocity, if you were to define the direction or determine the direction of angular quantities, how would you do that? So for example, if this is a circular object moving on a circular path, let's say this is a disk, okay? It's moving on a circular path. The angular velocity and angular acceleration is always directed perpendicular to the axis of rotation, okay? This was linear
Okay.
velocity. Angular velocity is always perpendicular to the rotational plane. Okay. Apart from that,
Okay.
alpha, which is angular acceleration, is also perpendicular to this plane. There's a relationship between alpha and acceleration, linear acceleration. Linear acceleration is the acceleration of this velocity. Angular acceleration is the acceleration of this velocity. It's telling you how quickly the angle is changing. But the same relationship applies. You just need to put a radius here. A is equals to R alpha. A equals R alpha. So relationship it applies. So the relationship between linear and angular quantities, S equals R theta, remember that's the first relationship. V is equals to R omega, that's the second relationship. A is equals to R alpha, that's the third relationship. And all three of them, you can see that it's only radius that is being the common quantity. Then moving on, angular displacement, revolution, degree, and radian done, right? Degree, radian, all of that stuff done. Angular displacement expressed in radians done. Then this is done. Angular velocity also done, right? Omega, which is 2 pi r. Now find out the relationship between linear and angular displacements, done. Linear and angular velocities, done. Linear and angular accelerations, done. Okay, now we act technically that's all that's required in this syllabus. Okay, this is all the
Yeah.
requirement of the syllabus, but it doesn't have like a lot of important stuff. So just to be on a safe side, I'm going to give you those formulas. Okay. These formulas include the formula for calculation of centripetal force. Centripetal force is mass times centripetal acceleration, right? Any force is mass times acceleration. But the centripetal force, the centripetal acceleration has two formulas which are important. One is mv squared over r, and the other one is mr omega squared. Even though they are not explicitly mentioned in the syllabus, you need to know this. Okay? Just
Okay.
to be on a safe side. Yeah, that's pretty much circular motion in the syllabus. Understood, guys?
Yes.
And what's the cause of circular motion? The cause of circular motion is always Fc, okay? Fc is the
Okay.
centripetal force. There's a lot of stuff which is not mentioned in the syllabus, so you don't need to do that.